Hi everyone, so we'll be looking at the topic on carbonates. So let's start to write the chemical formula of these substances. So calcium oxide, calcium has valency 2, oxygen valency 2, so CaO. Pause the video, try to write these formula, and then you can check your answers. So calcium carbonate, CaCO3, calcium hydroxide, CaOH, bracket twice. So just to show you the process, so valency 2, CaCO3, calcium hydroxide, calcium valency 2, hydroxide valency 1, so CaOH. You have a radical that gets a valency of 2, so you have to use brackets. Now, limestone, it's a solid that is formed when you have the structure of animals from the sea. So you have shells that deposit, that become cemented together. So very small solids, very small pieces of shells that deposit over the years and that solidify until they form a rock, which is called limestone. And limestone contains calcium carbonate, CaCO3. Make a little change here. This is limestone. So chalk and marble also contain limestone, calcium carbonate. Limestone is used in the manufacture of cement. So it's mixed with clay, it's heated in a rotary kiln. We'll see the kiln in a few minutes. And it's used to produce cement. It's also used in the manufacture of iron. So in the manufacture of iron, we're going to add calcium carbonate, limestone, and when we extract iron, we're actually heating at a very high temperature. So in the presence of heat, you have thermal decomposition of the carbonate. It gives you carbon dioxide and the oxide. And this quicklime, if you look at this is a metal oxide. And if you remember, metal oxides, these are basic oxides. Because it is a basic oxide, it is going to react with acidic substances. So when you are extracting iron, actually, you start with a rock that contains iron. And this rock contains iron, but it also contains impurities like silicon dioxide, which is basically sand. Now, silicon dioxide, this is a non-metal oxide, and non-metal oxide are acidic oxides. So you have an acidic oxide, which is from the rock, so which is sand, and you are adding calcium carbonate, which is going to decompose to give you calcium oxide, which is a basic oxide. So then you have an acidic oxide and a basic oxide. What's going to happen is you'll have a reaction, and this kind of a neutralization reaction that happens. So silicon dioxide reacts with calcium oxide, gives you calcium silicate, which is a salt. And this is what happens to remove acidic impurities. Silicon dioxide, that's sand. This is an acidic impurity. And this results in calcium silicate, which is also called slag. This is discarded. So in the blast furnace is a structure in which the rock containing iron is put inside the blast furnace, and where you have the reactions that will take place in order to produce iron, molten iron. So you have to write the chemical equations that lead to the formation of slag starting from limestone. So these are the equations. Now, limestone is also used in the manufacture of glass. It's also used to manufacture lime. It's also used to neutralize soils and lakes that is caused by acid way. So these are all the uses of calcium carbonate that you need to know. Now, thermal decomposition of limestone. So when heated strongly, calcium carbonate is going to decompose, undergo thermal decomposition. Thermal means heat, decomposition means breakdown. Normally, carbonates will decompose when heated, and they will give you the metal oxide, and they will give you carbon dioxide. So here, calcium carbonate is going to decompose. Here it's saying that it's a reversible reaction. Yeah, it gives you calcium oxide plus carbon dioxide. And this is normally a reversible reaction when it's going to be undergone in a closed system. What does that mean? Now, a closed system is a system where nothing gets in and nothing gets out. So when calcium carbonate is in a closed system and that you're heating it, whatever carbon dioxide is formed can combine again with the calcium oxide because it's a closed system. All these remain together. So when these combine together, you have calcium carbonate, which is formed again. So in a closed system, this reaction is reversible. So you'll have a mixture of reactants and products. But if you do that reaction in an open system is where substances can leave, you have that carbon dioxide that is going to leave into the atmosphere. And when this leaves, so calcium oxide does not combine with more carbon dioxide. So then the reaction becomes irreversible. So in an open system, this is the reaction that takes place, and this is what we want when we're making calcium oxide. We don't want it to combine and form calcium carbonate again. So when we manufacture calcium oxide in a lime kiln, we're going to ensure that this carbon dioxide can escape. So here you have a diagram of a lime kiln, and you have the carbon dioxide that is going to escape from the top. And in here, you're going to have limestone that is going to be heated. So you have fuel in and hot air in. So this is going to give you the temperature, because you need limestone to decompose due to heat. And once the decomposition takes place, carbon dioxide leaves, you have calcium oxide that is going to be produced, and this is our lime. So these are the different steps. You can go through these steps that take place in the lime kiln, which is a very important industrial process that is going to produce lime. Now, another form of lime is slaked lime. Slaked lime is calcium hydroxide. Now, calcium hydroxide can exist in two forms. You can have solid calcium hydroxide or aqueous calcium hydroxide. Solid calcium hydroxide is called slaked lime, and aqueous calcium hydroxide, this is what is called lime water. This is what you know as being lime water. So slaked lime is CaOH twice, and it's made by adding quicklime to water. So quicklime added to water, this is going to give you CaOH twice. Now, slaked lime is also, like in the aqueous state, this is also called lime water, and it's used to test for the presence of carbon dioxide. And in the presence of carbon dioxide, when you bubble carbon dioxide in calcium hydroxide in lime water, you have the formation of calcium carbonate. And calcium carbonate is insoluble in water. It's white, so you have a white kind of a precipitate, white substance, white precipitate which is formed. This is why carbon dioxide turns lime water milky, because you have that formation of calcium carbonate, which is white. Now you have to be able to remember the different names of the lime substances. I'll show you a little trick that I used. Now lime and quicklime is the same. Okay, so quicklime, if you write calcium oxide, CaO, you can change that O to a Q. So this is quicklime. And calcium carbonate, CaCO3, calcium carbonate, this is a solid, it's a rock, and all carbonates generally are insoluble, they are solids. So this is a rock. So this is limestone. So because it's a solid, so a rock, this is stone, limestone. And then lime water, this is water H2O, so CaOH twice, and because it's water, it's in the aqueous state. And then you'll have slaked lime, which is left. Slaked lime is basically the solid version of lime water. Right. Now, quicklime and slaked lime, these are used to treat excess acidity in soil, and these are used for flue gas desulfurization. Now, when you have coal and petroleum, these normally contain sulfur impurities, and when you're burning coal and petroleum, the sulfur is going to react with oxygen during the burning and is going to produce sulfur dioxide, which is dangerous. It causes acid rain, and it also causes breathing problems. Now you can remove the sulfur dioxide by passing it through calcium carbonate, calcium oxide, or calcium hydroxide. So what happens is that this is acidic, and as I mentioned before, calcium oxide, this is basic. It's a metal oxide, so it's a basic oxide. So basic oxide and acidic oxide, they will react together. So sulfur dioxide will react with calcium oxide, is going to produce calcium sulfide, CaSO3. And calcium sulfide formed is going to react with oxygen in air and water. So calcium sulfide formed will react with oxygen and water to form hydrated calcium sulfate. That's the formula. CaSO4 dot. So here, and we balance the equation, 2 here and half here. Normally, if it's a diatomic molecule, you can put half to balance. So here you have the balanced equation, and if you still remember, this kind of water is called water of crystallization, and it basically means that there is water inside in this structure, and this water makes that salt hydrated. You can drive it off by heating it, you get rid of the water. So this is how sulfur dioxide is eliminated in smokes or in fumes of factories. So with this, we end the topic on carbonates. You have the past exam paper questions. So work these out, and then I will send the answers to you.